1 second in 100 million years? That's how accurate our current atomic clocks are. Basically, they compare atoms, which are like tiny tick-tockers, to an even tinier, more precise tick-tocker. They call it a cesium fountain. I kid you not. Anyway, to anyone who's not a scientist, that level of accuracy is basically useless. Like, you're never going to need to know the exact time. But for people whose jobs involve super high stakes, it makes all the difference. Like global positioning systems, satellite navigation, network synchronization, internet telecommunications, secure data encryption, and quantum computing, just to name a few, according to the U.S. National Institute of Standards and Technology. Today's atomic clocks lose only 1 second every several hundred million years. For the entire universe, that's around 137 billion seconds. Now, this isn't news. We've had pretty accurate clocks for decades. It's just that, until recently, the idea of making them any more accurate hasn't really been on the menu. But what if you could wear a watch that's not just accurate, but dead on? Like, seriously, a watch that tells you the age of the universe, give or take a second. Yeah, that would be a watch worth having. So recently, scientists did what scientists often do. They broke something that was already working perfectly. I mean, atomic clocks were already accurate to 1 second in 100 million years. That's good enough for the average person trying to get to work on time, unless your job involves teleporting. But these quantum wizards weren't satisfied. They said, why not use quantum entanglement, dicoherence control, and double-hand interference to make clocks that are insanely better? No normal Tuesday stuff. And that's why you should subscribe to this channel. Every week we break down the most mind-bending space, science, and tech stories so you can sound smart when people bring them up. So here's what happened. Researchers at a university in Germany used a device called a sapphire oscillator and did what they do best. They made an almost unbelievably precise clock. They combined two different methods of generating time: standard approach based on bouncing light waves off mirrors, and a cutting-edge method that harnesses the strangeness of quantum mechanics. The result is a clock that's so accurate its equivalent in seconds would be less than the age of the universe. By the way, if you want to hear more about how scientists are putting quantum physics to use, you should check out our episode on quantum computers. To explain how this clock works, we have to talk about interference. No, not the kind you get from Wi-Fi dead zones, but the kind that happens when two waves overlap. If they meet in a crest, like the top of a wave, they reinforce each other. If they meet in a trough, like the bottom of a wave, they cancel each other out. Now, you've probably seen this if you've ever dropped a pebble into a pond and watched the ripples spread. When two ripples meet, they either make a bigger ripple or flatten out to nothing. It's the same with light waves. By understanding how these waves interact, scientists can create incredibly precise timepieces. The first step is to split a laser beam into two parts. This isn't that hard to do with some clever optics. Then they bounce each part off a mirror, like a little game of ping pong. The trick is getting the beams to line up again. After the mirrors do their thing, the beams of light come back together. If they line up just right, they amplify each other, creating a bright spot. If they're off by even a tiny bit, they cancel each other out, creating darkness. By counting how many times they line up, or don't line up, they can keep track of time. This is the basis of what's known as an optical lattice clock. But there's another way to count time using atoms. In an atomic clock, you find an element with an atom that vibrates or oscillates at a predictable rate, like a tiny metronome. The rate is so consistent that you can use it to define the length of a second. For example, in 1967, the International Telecommunications Union defined the second as the duration of 9,192,631,770 periods of radiation emitted by a cesium-133 atom in its ground state. Basically, you pick a type of radiation that comes off an atom. Whenever the atom goes from one energy level to another, then each cycle of that radiation represents 1 second. Scientists can measure that radiation with incredible precision, giving us clocks that are accurate to within 1 second in millions of years. These two methods are pretty different, but they have one thing in common. They both involve interference. In the case of the atomic clock, the interference is happening at the level of atoms, and in the case of the optical clock, it's happening with the photons of light. So what if you could combine the two? Scientists thought it was a good idea, but it wasn't easy to pull off. It turns out that making an accurate clock using atoms and a clock using light, Do ain't quite line up because of differences in how they measure time. Basically, they're speaking different time languages. In a recent study, researchers found a way to make them understand each other. They took a sapphire crystal and bombarded it with a laser beam. The laser caused electrons in the sapphire to vibrate in a regular pattern, much like the atoms in an atomic clock. This vibration became entangled with the light wave in the setup, like two people holding hands and spinning around. The electrons and photons seemed to communicate instantly, no matter how far apart they were. This allowed the researchers to generate a clock signal. Based on the vibrations of the sapphire lattice and the interference pattern of the light, this is pretty cool. It's like mixing two types of music together, but instead of sound waves, you're dealing with light and matter. The final result is a clock that's 100 times more accurate than the current state-of-the-art. Now you're probably wondering who needs an insanely accurate clock. As it turns out, quite a few people. For starters, there's the European Space Agency. In the near future, they want to launch a mission to determine the strength of gravity near a black hole. To do that, they need a clock accurate to within 1 part in 10 trillion. In addition, better clocks will help improve the accuracy of GPS and quantum computers. They'll also allow scientists to test theories about the nature of time itself. For example, physicists believe that time should pass slightly more slowly on Earth's surface than far away from any massive objects. Einstein's theory of general relativity predicts that the gravitational field of Earth should cause time to slow down by around 1 millisecond per day. While that's not exactly noticeable to us fleshy meat sacks, it's a big deal for scientists trying to understand the universe. With a clock accurate enough to measure these tiny variations in time, scientists can test theories about how gravity works and search for signs of dark matter. Not too shabby for a clock that fits in your pocket. Obviously, there are a ton of applications that better clocks will unlock. But they're also great because they show us how creative humans can be. Like we aren't content with the status quo. We always want to push the limits of what's possible. And who knows, maybe someday we'll discover that time travel is actually possible. Better clocks would certainly help. In the meantime, though, I think it's time for a coffee break. My coffee's gone cold, so I'm off to get a fresh cup. Thanks for tuning in and sticking with us through this crazy experiment. Our team spent months putting this together, and we hope you enjoyed it. If you did, please let us know with a like and comment. If you didn't, well, don't worry. We won't be seeing you next week when we're back to our regularly scheduled programming. Till then, remember to look up and keep thinking.